Until recently, we've mostly looked at terms and expressions containing only one term, such as 3 square root of 2 or 2x over y. However, much of our work will require us to work with a string or addition of these terms. One such group of terms might look like x squared plus 4x, which we call a binomial. Bi meaning two, nomial meaning term. In other words, we have a two-part number. These strings of terms are called polynomials. There are three types of polynomials that are most well known and worked with, which we'll explore in this chapter. So now is a good time to introduce a bit of vocabulary. Monomial. This is what we mostly worked with in the previous lessons. They're expressions of a single term, hence mono. A single term, constant, or variable is called a monomial. Examples are 4x cubed or 3x squared y cubed. Next is binomial, which we mentioned a short while ago. A binomial is an addition or subtraction of two terms of different variable basis. For example, x squared plus x, or x plus y. We state that the terms must include differing variable bases because if the bases can be combined, such as 3x plus 2x, we can simplify it to a monomial, 5x, which isn't a binomial. Also, a binomial may have a constant for one of the terms, but not for both. For example, 3x plus 1, or y squared minus 1. The third most common type is called a trinomial, meaning a three-part number. Most commonly here in algebra, we'll explore a specific type of trinomial called a quadratic. We'll explore the math behind quadratics in the future chapter. For now, we're just getting acquainted with the basic operations on equations and expressions of that form. A quadratic has a descending exponential value for each of the preceding terms. For example, x squared plus x plus 1. Other trinomials may look like this: 2y cubed minus 2y squared plus 4y. We call that a variable with an exponential value of 0 is 1. Thus, we don't have a value on this last term in the quadratic form. With the three main types of polynomials introduced, we introduce a characteristic of polynomials: degree. Degree is a term given to the sum of all the exponents in a single term. Looking back at our examples for monomial, the degree of 4 is 0. The degree of x cubed is 3. And the degree of 3x squared y cubed is 5. To understand the degree of the constant, notice that you would have to have a variable of exponential power 0, which equals 1. So therefore, we don't have to write that, but it still means that the constant term has a degree of 0. Now, with the introduction of quadratics as a formal type of expression in our trinomial section, we need a name to identify the type or level of expression we have. What we're going to use is called the degree of the polynomial. The degree of the polynomial is going to refer to the highest exponent present in an expression or equation. So if we have a quadratic expression such as x squared plus x plus 1, we would say its degree is 2 because of the exponent of 2. If our expression looked like 6x cubed minus 4x squared y squared, we would say its degree is 4 because the second term has the higher degree than the first term. Our first work with polynomials would be to add and subtract them. This operation is actually no different than adding like terms, such as our work with operations on exponents. Basically, any terms that contain like variables of the same degree can be added or subtracted. After we combine our terms, we order the expression with the highest exponent first, ending with our constant if applicable. For example, let's say we have two trinomials, x squared minus 3x plus 3 and 2x squared plus x minus 4. Both of our trinomials are in simplest form because there are no like terms that can be combined. Now, if I wanted to add the two trinomials together, we'll group them together with parentheses and add them together like this. X squared minus 3x plus 3 plus 2x squared plus x minus 4. Since we can see that each term has a like term with the other, we can simply add each term together. We'll do each term one at a time at first to keep it slow. X squared plus 2x squared plus negative 3x plus x plus 3 plus negative 4. Notice that we use the addition sign between the two trinomials to add each separate term together, whether that specific term was positive or negative. Simplifying this gives us 3x squared minus 2x minus 1. The process is the same if we wanted to subtract our two trinomials. Say we wanted to subtract 2x squared plus x minus 4 from x squared minus 3x plus 3. We would have x squared minus 3x plus 3 minus 2x squared plus x minus 4. Using the same process of grouping like terms together, we get x squared minus 2x squared plus negative 3x minus x plus 3 minus negative 4. Notice that we use addition signs in between each group. As long as we use the subtraction sign within each group, and be careful not to forget our signs associated with each term, such as the negative 4 or the negative 3x, we'll get our correct answer. Our expression becomes negative x squared minus 4x plus 7. The only difficulty in this is being sure not to lose track of your negative signs, such as the 3 minus negative 4, which becomes 7. The middle term can be confusing too, but remember that positive negative 3x minus x equals that positive negative 4x, which is negative 4x. Before moving on to some examples, I want to give you the definition of the standard form of a polynomial. Earlier, I mentioned that you always want the highest degree term at the front of a polynomial. That is what puts a polynomial in standard form. The standard form of a polynomial of degree n in the x variable is a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus and so forth on to plus a sub 2 x squared plus a sub 1 x plus a sub 0, where a cannot equal 0 and n is a non-negative integer. This looks very daunting, but it's simply an explanation of what we want when we need a polynomial in standard form. First, a is our coefficient for each variable x. Notice that each term has an x variable except for the last one, which is our constant, because x to the 0 power equals 1. Now look at the first term, a sub n times x to the n power. The lower n is called a subscript, and the upper n is called a superscript. Sometimes when writing definitions and proofs, it's prudent to name our coefficients. Here, we named our first coefficient a sub n. We're naming this coefficient a sub n because it's reflecting the degree of that term. The next term simply wants us to list the term with the next highest exponent, or 1 less than n. The a sub n minus 1 just lets us know that that specific a is associated with the x to the n minus 1 variable. The name of the variable is going to reflect the power of its variable. We do this on and on, signified by the ellipses, until we get to our constant. After ordering our polynomial thus, we will be in standard form. Now we'll work a few examples. For these 3 examples, identify its degree and put it in standard form. Number 1, 2x plus 3x squared plus 5x to the 5th power minus 4x cubed. Notice that this polynomial has 4 terms, meaning it's not any of the 3 types of polynomials we learned. Polynomials can have any number of terms. We begin by looking for the term containing the highest degree, which we see is 5x to the 5th power. Therefore, the degree of this polynomial is 5. Now we begin to put the polynomial in standard form. We start by placing the highest degree in front, then followed by each term of degree 1 less than the previous. We should end up with 5x to the 5th power minus 4x cubed plus 3x squared plus 2x. Number 2. This trinomial contains 2 different variables. Refer back to our definition. The standard form of a polynomial of degree n and the variable x is. We want to set up this polynomial in the standard form with reference to the x variable. In other words, we line up the terms containing x, then we work with the others. So starting with the x terms, we see our degree is 2, so we want that term in front, x squared. We then have one more term in x, negative 2xy, but it's also in y. But the term is degree 1 in x, so we place it after the first term, minus 2xy. We then have the term y squared left, and place it at the tail of the polynomial, x squared minus 2xy plus y squared. Number 3, 3x squared y plus y squared plus 3 cubed plus 3xy squared plus y cubed. Now we have a polynomial with 5 terms. Starting with x, we find our highest degree term, which is x cubed. Therefore, our degree is 3, and we put the x cubed in front. And then we follow it by terms of lesser degree of x. I see a 3x squared y and a 3xy squared. Now we have 2 terms left in y. We simply do the same thing for those, all of them with the highest degree first, plus y cubed plus y squared. Now that we have some skill in arranging polynomials into standard form, let's do a few more examples of operations on polynomials. Number 1, 3x squared plus 4x plus 5 plus 2x squared plus 7x plus 2. We have 2 trinomials, both in degree 2, that are being added together. We are going to simply add the like terms together. Because our trinomials are already in standard form, as long as we add from left to right, our sum will also be in standard form. We have 5x squared plus 11x plus 3. Number 2, 5x to the 4th minus 3x squared plus 9 minus 3x cubed minus 2x squared minus 7x plus 3. This time, we have 2 polynomials, one with 3 terms, the other with 4. We can still add the 2 together, we just need to make sure we only add like terms. The first term is degree 4, but the first term in the second polynomial is degree 3. Neither of the 2 polynomials share this degree, so we won't be adding these terms. So we'll just leave them be. 5x to the 4th minus 3x cubed. Both polynomials have a term of degree 2, so those will be added. Negative 3x squared minus negative 2x squared. That becomes negative x squared. Only the second polynomial has a term in degree 1, that negative 7x. That becomes positive 7x. And both terms end with a constant. That would be positive 6. Your polynomial should look like this. 5x to the 4th minus 3x cubed minus x squared plus 7x plus 6. We have only touched the surface of what can be done with polynomials. Polynomials are such an integral part of algebra. This lesson covered ordering polynomials in their standard form and operations on them. But there are many more operations that can be done, such as multiplication and division. Division of polynomials will be a few chapters ahead because it can be a little bit more advanced. But for the next lesson, we will cover multiplication of polynomials, specifically a method known as FOIL.